This time on the bench is an IWC from the 1960s. You'll see that this timepiece will require quite a bit of work to get in a healthy shape. Let's inspect the case a bit. It is pretty bad. Rust and old gunk in a lot of spots. Here on the flanks and especially in between the lugs. We'll clean that later and try to remove the rust from the case. Hopefully, the rust hasn't gone too deep in the metal. Let's open up the case. This is a clipped-on case back, so in order to remove it, I need to insert a blade in a slot designed to this effect somewhere around the case. I cover it with a piece of plastic to avoid any undesired scratches. Here is the movement. It is looking really nice as usual, with these IWC calibers of that era. It is known as a peloton caliber. This name refers to a bidirectional winding system. It is one of the main features of IWC's history in terms of achievements in watchmaking. Let's dive in a bit more deeply into its functioning. Basically, the swings of the rotor drive a heart-shaped cam plate, which then gives the pawel carrier a back-and-forth motion, which engages a set of two pawls. These pawls are like a pair of climbing acts. They anchor themselves with the ratchet wheels to wind the mainspring. It is a durable and shock-absorbing solution to the automatic winding problem. This is a caliber 853. It is an update to the previous caliber 852, and was launched around 1958. Here's the inside of the case back with some rust on the lip. I'll do my best scrubbing that off later on. Some interesting infos in there. On the bottom is the reference of the watch, and above is the case serial number. This info will come in handy later to date this particular watch. Let's disassemble the automatic module. I'll start by the cock linked to the rotor. This is a very recognizable automatic module and very distinctive of IWC. After the rotor removed, you can see the specificity of the automatic module in the flesh. Here are the pawel carrier and the peculiar ratchet wheel, both held by the same bridge. The ratchet wheel has specific teeth that are obliquely profiled in order to get the two pawls to properly anchor themselves. On the underside of this wheel, there is a pinion transmitting the energy to the winding wheel. It is the smaller one represented in bright green in the little animation I made. The issue when designing a bidirectional winding system is the fact that the mainspring can only be wound in one direction of rotation. Here, the two pawls help to always turn the ratchet wheel in the same direction for both directions of rotation of the rotor. Here is the second serial number, which refers to the movement this time. With both the case and movement serial numbers, an approximate year for the watch can be determined. For IWCs, the Date Your IWC website is my reference. Here it is, about 1963 for the movement, and between 66 and 69 for the case. This makes this specific watch around 60 years old. As usual, the balance is removed as soon as possible. This part alone is nicely finished with black polish and Geneva stripes. Another really nice point of this movement is that it has a Breguet hairspring, also known as a Breguet overcoil. It is a specialized type of balance spring used to improve timekeeping accuracy and stability. It was invented by Abraham Louis Breguet in the late 18th century as an enhancement over the traditional flat hairspring. Unlike a standard flat hairspring, which lies entirely in one plane, the Breguet hairspring has an upward curving final coil. This overcoil shape reduces positional error and improves isochronism, meaning the watch is better at maintaining the same rate regardless of the amplitude of the balance wheel. We can see lots of rust on the edge of the case. Even the crown stem is affected by the rust. Luckily, it hasn't gone inside the watch and affected the movement in itself. We'll have to remove all of that rust later on. Continuing the disassembly with the bezel. With this type of construction, the movement and dial can only be removed from the front, so the clip-on bezel needs to be removed just like the case back. The glass is maintained with the bezel. Its size slightly exceeds the bezel's inner diameter, allowing it to be held in place through tension with the bezel's inner lip. Here it is. The glass is heavily scratched up. It will be replaced with a new one later on. This is an easy task. I just need to measure the diameter of the inner lip of the bezel and get a generic acrylic glass on the internet. The dial is really nice looking, with its silver sunray finish and cursive IWC logo. These watches represent a lot of watchmaking, considering the price they can be had for, let's say between 500 and a couple of thousands euros or dollars, depending on the condition and the case material. The hands are now removed. These are nice Dauphine hands. There is a plethora of hands type with a specific name for each style. Alpha hands, which are narrow near the center, wider in the middle and with a tapering to a point. Leaf hands, slender and shaped like a leaf. Breguet hands, looped tip, very refined and traditional. Very often, with these vintage watches, a dial washer is missing. It acts as a spring between the dial and the hour wheel and keeps this wheel in place and engaged with the rest of the keyless work. A new one will be added during reassembly later on. Let's get deeper in the disassembly. The dial is now removed and safely stored. Same goes for the hour wheel and cannon pinion. The movement is getting on a movement holder for further dismantling. As said earlier, one of the main features of these IWC movements from that era is the automatic module. Automatic wristwatches were introduced in 1929 by Harwood, a British watchmaker. Early mechanisms had technical limitations. In 1931, Rolex patented its Oyster perpetual movement with a unidirectional rotor. By the late 1930s, other companies like ETA developed more complicated automatic winding systems. Between 1944 and 1955, around 200 patents for such mechanisms were granted. IWC joined the race in 1944 when Albert Pelleton, the technical director of IWC, began developing an automatic winding system. His first 1946 design was patented, but never produced. In 1950, his second design led to the Caliber 81, with only 1800 made in between 1950 and 51. Also in 1950, IWC introduced another automatic movement, the Central Seconds Caliber 85. This movement used the Pelleton winding system, which had many advantages. It was easy to disassemble for service, and it offered shock resistance. It also was efficient in winding. While the mechanism was unique to IWC and patented, its concepts had antecedents. For instance, Longines used eccentric winding in a 1945 model. On the other side of the globe, Seiko approached the same problem with a completely different philosophy, one rooted in simplicity, durability, and efficiency. While Swiss manufacturers often leaned toward intricate gearing systems, Seiko sought a solution that could be both highly functional and easy to produce. Their answer? The magic lever. Introduced in the late 1950s, the magic lever is a brilliant example of minimalist engineering. Rather than using a series of gears or cams to transfer motion from the rotor to the mainspring, Seiko designed a two-pronged spring-loaded lever that engages directly with the ratchet wheel. As the rotor moves, regardless of direction, the lever rocks back and forth, pushing the ratchet wheel and winding the mainspring with every oscillation. The real beauty of the system lies in its bidirectional winding, mechanical simplicity, and low part count. With fewer components, there's less friction, less wear, and less to go wrong. It's a design that not only ensures smooth operation, but it also makes servicing faster and more affordable. In true Seiko fashion, it's not about the most elegant solution, it's about performance. The magic lever doesn't try to impress with visual complexity. Instead, it quietly and reliably does its job. And over 60 years later, Seiko is still using the same system in many of its automatic movements, a testament to just how well it works. The next step involves disassembling the shock system jewels. This watch features the Inca block system, one of the most widely used designs in watchmaking. Developed in the 1930s, the Inca block system became the industry standard by the 1950s. Its iconic lyre-shaped spring protects the delicate pivots of the balance wheel from impact damage, an essential feature for watches that endure everyday wear and tear. We're almost done, with the dismantling now. If you have followed and are familiar with these kind of videos, a last part needs dismantling and checkup. Now, it's time for the mainspring barrel to be disassembled. This is where the energy of the whole watch is stored. It is the strongest spring of the whole movement. When you wind the watch, manually or through automatic movement, you're tightening this spring, usually made from special alloys like Nivaflex. This material is anti-magnetic, corrosion resistant, and designed to deliver consistent torque. As it unwinds, it releases energy gradually, powering the gear train and ultimately moving the hands. The barrel often has tiny gear teeth on its edge, allowing it to transmit that force efficiently. A mainspring in good shape ensures consistent amplitude and timekeeping, making it a critical part of a watch's precision and reliability. The disassembly is now completed. Here are all the parts. It is time for cleaning. Whilst the movement parts are getting cleaned in the machine, let's take care of the rusty case parts. The mid-case and caseback have a lot of rusty spots. The majority of them appear to be not too deep into the metal. The glass is all scratched up. It will be replaced later on. The bezel also have some rust. Here are the sides of the case. Some rust there as well. I'll start by removing the bulk of the rust with some pegwood. No quick solution here, some good old elbow grease and some time required. I'll make it faster thanks to the magic of editing. Back then, many watches used clip-on casebacks with no rubber gasket, meaning they weren't truly sealed. Even normal daily use, like hand washing, sweating, or humid environments can allow microscopic moisture to seep inside. Once that moisture is in, it has nowhere to go. Over time, it settles in hidden spots, under the caseback, around the crown tube, or even inside the movement. Stainless steel does resist corrosion, but it's not immune, especially when sweat or acidic residue are left untreated. In many vintage watches, rust starts slow and silent, only showing signs years later. That's why regular servicing and proper storage are so important. The rest of the rust will get eaten by this evaporous solution. I'm just gonna let the parts sit in there for some time and let the product take care of the smaller rust portions still there after the manual cleaning. Alright, the cleaning machine has done its work and the parts are ready. It's time for the reassembly. It's all clean and shiny now. Let's start with the balance wheel and its 2 jewels. The cap jewel is oiled with some low viscosity oil. A tiny amount covering about 2/3 of the surface is dropped on the jewel. The same is done to the other side of the balance staff. Cap jewels are found at both ends of the balance staff, the most delicate pivot in the entire watch. Unlike standard jewels with holes, cap jewels are flat and sit on top, helping to limit vertical play and reduce friction. They also keep a tiny droplet of oil in place, ensuring smooth rotation of the balance. Most watches pair them with a shock protection system like the Inca block on this one, which holds the cap jewel and allows it to flex slightly during impact. Now it's time to fit a brand new mainspring into the barrel. Since this is an automatic movement, some braking grease is needed. I fill the wall of the barrel with a light film of this dark grease. Its high viscosity makes it a great choice in the barrel. Its main purpose is to regulate how the mainspring unwinds, ensuring smooth and controlled energy release. A brand new mainspring is then fitted into the barrel. Always start by the end of the spring so that the rest of it follows. Next is the arbor. It is fitted according to a slot in the end of the mainspring. A touch of oil on the top of it, where the lid is in contact. Lid that is then press fitted with that little tool. It gives an even amount of pressure all around the lid. And we've got a barrel ready to get back on the plate. While I am assembling the movement, let's talk about IWC's history. Unlike many Swiss brands, IWC has a unique history that blends Swiss craftsmanship with American industrial efficiency. IWC was started way back in 1868 by an American watchmaker named Florentine Ariosto Jones. Back then, Jones was working as a director at E. Howard and Company in Boston. But then, Jones had this big dream of making top-notch Swiss watches using American-style industrial manufacturing. His goal was to combine Swiss expertise in movement finishing with mass production techniques to create precise and affordable timepieces. Despite initial struggles, IWC thrived by creating robust pocket watches featuring state-of-the-art calibers. By the early 1900s, it developed highly accurate wristwatches and specialized in movement for professional use. In 1936, IWC introduced the pilot's watch, designed for aviators. This laid the foundation for the legendary Big Pilot and Mark series, which remain icons today. During World War II, IWC was commissioned to produce durable and highly legible military watches. Around the same time, in 1939, the company created the first Portuguese watch, featuring a large pocket watch movement inside a wristwatch case. An unconventional design at the time, but now one of IWC's most famous collection. In 1950, IWC introduced the Peloton winding system, an innovative automatic winding mechanism that significantly improved efficiency. This system remains a key feature in modern IWC automatic watches. In the 1960s and 1970s, IWC continued developing high-end mechanical movements, but also experimented with quartz technology during the Swiss quartz crisis. However, the brand remained committed to mechanical excellence, leading to the revival of traditional watchmaking in the 1980s. In 2000, IWC joined the Richemont Group. Today, they're famous for their pilot's watches, like the Big Pilot and Mark series, the Portugieser, the Engineer, the Aquatimer, and the Da Vinci and Perpetual calendars. In 2024, IWC sold approximately 120,000 watches, a decline from 137,000 units in 2023, with an average retail price of around 6,049 Swiss francs. Like the case parts, the crown stem deserves a bath in the anti-rust solution. This solution is called Evaporist. It is a water-based rust remover that's non-toxic and highly effective. It dissolves rust without scrubbing. Here's the result after some time. It's looking like new. Another aspect of IWC that I find particularly compelling is its ability to offer high complications in relatively affordable and robust timepieces. This achievement is made possible through collaborations with talented watchmakers who have shaped IWC's rich history. From perpetual calendars and minute repeaters to split-seconds chronographs, each complication is tied to a legendary watchmaker who left an iconic mark on the brand. IWC has taken a pragmatic approach to making these complications more accessible, often building on reliable ETA calibers and transforming them in-house to meet their standards of precision and innovation. In the 1980s, Kurt Klaus revolutionized the brand's approach with his perpetual calendar mechanism, developed during the height of the quartz crisis. This ingenious system could automatically account for leap years, varying month lengths, and century changes, all adjustable through a single crown. IWC's minute repeater complication reached new heights under the supervision of Dominique Renaud and Giulio Papi, whose collaboration led to the creation of the Il Destriero Scafusia in 1993. This grand complication, created for IWC's 125th anniversary, combined a tourbillon, a perpetual calendar, and a minute repeater. Richard Hubring introduced a more accessible split-seconds chronograph in 1992, featured in the pilot's watch doppelchronograph. Now that the assembly is almost complete, it's time for lubrication. For the gear train pivots, we use low-viscosity oils to reduce friction without slowing the motion. These oils must be stable, long-lasting, and resistant to temperature changes. Too much, and it spreads where it shouldn't. Too little, and the pivots wear prematurely. The goal is just a tiny droplet, right at the jewel, to keep the gears moving freely for years without compromising accuracy. The moment of truth is almost there. The balance wheel is next to be fitted back on the plate. When refitting the balance wheel, alignment is critical. In a Swiss lever escapement, the impulse jewel on the roller needs to sit correctly relative to the pallet fork. As you lower the balance into place, the impulse jewel should land just behind the fork horn, not pushing directly against it. If it lands on the wrong side, or the fork is misaligned, the wheel will stop or bounce erratically. A light nudge of the pallet fork might be needed to let the jewel enter smoothly. Now I'll let the oil sit for a couple of hours. It allows them to settle evenly into the jewels and pivots. After that, it's time to check the movement on the time grapher and do the regulation. The time grapher gives important measures: the watch's rate, amplitude, and beat error. All key indicators of how well the movement is running. It is used after reassembly to check if the watch is gaining or losing time, to see if the balance amplitude is within healthy range and if the beat error is within decent margins. Here the amplitude is pretty good. However, the rate and beat error need some tweaking. Let's start with the beat error. The beat error is the difference in duration between the clockwise swing and the counterclockwise swing of the balance. In perfect conditions, the beat error is 0, and under 1 millisecond, in every position at least. On this movement, the beat error adjustment has to be done directly on the collet of the wheel. Basically, the collet here represented in white is slightly rotated on its axis. It changes the position of the balance spring. After some back and forth and some timing regulation, here are the final numbers. I usually work with 4 positions: dial up and down, and crown up and down. Regulating a watch in multiple positions is essential because gravity affects how the balance behaves. A watch might run spot on dial up and terrible crown down, so checking several positions ensures consistent timekeeping on the wrist, no matter how it's worn. I am pretty satisfied with the results I managed to get. The delta is the difference between the 2 furthest mean rates across all positions. I set the maximum acceptable to 15. Here, at 11.25, it is more than fair. Everything else is also very acceptable. Let's move on to the glass replacement. After some time in the anti-rust solution, the bezel is looking much better. A brand new glass is going to be fitted on the watch. I use this crystal press that bends the glass evenly so that I can fit the bezel onto it from under. I then release the pressure to allow the crystal to take its shape back and sit properly around the bezel lip. Watches typically use one of 3 types of crystals: sapphire, mineral glass, or acrylic. Sapphire is the most scratch-resistant, mineral is a mid-range option, and acrylic, though the softest, is surprisingly practical, especially for vintage and tool watches. Acrylic is lightweight, shatter-resistant, and easy to polish out scratches, making it ideal for daily wear or rough environments. It also gives a warm, slightly domed look that many collectors love. Here's the dial washer talked about at the beginning of the video. The dial washer is a small but critical part that sits on top of the hour wheel, between the dial and the movement. Its job is to apply light pressure that keeps the hour wheel in proper contact with the rest of the keyless work. Without it, the hour wheel can lift slightly, leading to poor hand alignment or even gear disengagement. In vintage watches, dial washers are often missing, likely forgotten or left out during past servicing. I've just finished tightening the screws that secure the dial to the movement. Now it's time for the hands, back where they belong. Despite a few age-related blemishes here and there, the dial still carries a lot of charm. The finish catches the light beautifully, especially thanks to that sunburst texture. Sunburst dials, sometimes called sunray dials, are known for their radial finish that reflects light in a sweeping pattern from the center outward. That shimmering effect isn't painted on, it's actually machined. The dial blank is placed on a spinning lathe, and a fine abrasive tool is used to create tiny grooves radiating outward, almost like vinyl record lines. After that, layers of transparent lacquer or color are applied, allowing the texture to shine through and shift with every angle. It's a delicate process that requires precision and clean workshop conditions. The result is a dial that feels alive under the light, elegant, refined, and surprisingly complex for something that looks so simple. Using a press, I've just clipped the bezel back onto the case. We're nearly at the end of today's work. Only one part left, the glorious automatic module. With the movement almost fully assembled, it's the perfect moment to appreciate just how well finished the IWC Caliber 853 really is. For a movement designed in the 1950s, the level of care and refinement is remarkable. You'll find beautiful côtes de Genève on the bridges, beveled edges, black polished screw heads, and a thoughtfully organized movement layout. But it's not just about looks. This movement was built to perform with its Inca block, Breguet overcoil hairspring, and Peloton winding system. Compared to many mass-produced calibers of the same era, the 853 stands out not just for its finishing, but also for its engineering integrity even by today's standards. With all our CNC machines and modern methods, this movement holds on its own. It was built to last and be serviced. In an age where even high-end brands cut corners, the 853 stands out despite being over 6 decades old. It's a movement built to last not just years, but centuries. I have slightly brushed the case back. I usually don't do case refinishing myself, but little work like this one is within my range. Let's do a quick comparison and throw back to how the watch was at the beginning of the video versus how it looks now. Lots of rust and gunk, especially between the lugs. Now, the rust has been removed. It has still managed to eat some metal on the flank near the crown. It cleaned up pretty nicely in between the lugs. Overall, I am satisfied with the result I got. Tell me what you think in the comments. Here is the end result. It's been really pleasant to work on this timepiece. I'll see you on the next one.